Hello and welcome to my talk at the International Conference on Logistics and Supply Chain Engineering in 2021. My name is Becker and I'm a professor of information systems at the Faculty of Business Studies at the University of Applied Sciences in Emden and Leer in Germany. I'm extremely grateful that the conference organizers have granted me this opportunity to have my talk here at the conference. Now let's get started and please enjoy the talk. The title of my talk is Complex Networks in Manufacturing and Logistics, Models and Methods. We'll have a look at the topic of complex networks with a specific focus on logistics. We'll look at many different fields, transportation, manufacturing, infrastructure, and I want to give you an overview on this topic. We don't go too much into detail with all the different aspects of the topic, but I'll give you some information on how to do network modeling with logistics problems in logistics with the infrastructure, and I'll also show you some methodologies that you can use to do research and investigation if you have gathered the data that you can use to create network models in logistics. Before we start, I want to introduce myself, because I was always interested in information technology and how it impacts on processes, especially in businesses. I pursued a degree in information systems. After graduation, I joined PricewaterhouseCoopers as an IT auditor and consultant. I was mainly working in the field of audit, and I was supporting the auditors with all IT-related questions. We were looking at the IT systems that were helping to create the numbers and figures that were going into the accounting, so that this was also part of the annual audit, and there was more confidence in the actual numbers and in the audit when the IT experts had a glance at how these numbers were created. After that, I returned to university because I got an offer to do research in the field of international logistics. I was working on different projects. Especially I was working on computer simulations of logistics processes and supply chains. And that's when I started to work on the topic of complex networks, because I realized that everything that happens in logistics is networked, and there are many relations and interactions, and it would be very interesting to model this as complex networks. And that's when I received my PhD in international logistics, and afterwards I was appointed Professor of Production Systems and Logistics Systems at the University of Bremen in Germany. I continued to pursue my research interest of complex networks, and I did some research projects on this. And then a couple of years later, in 2018, I got an offer to become Professor of Information Systems at the University of Applied Sciences in Emden. And then I took the opportunity to return to my original profession, and that's where I am now, still working in the field of logistics, but also looking at everything that has to do with making processes in businesses digital, and of course also using numbers and data to achieve this goal. No business is an island. That's a quote from the book Logistics Network, unfortunately only available in German language up to now. And well, this is for me a very important sentence. It says that every company is connected with its suppliers, but also with the customers and other entities, such as authorities, and they also have different types of relationships. They are connected by exchanging goods, information, but also money. And this type of connectivity, this is the prerequisite for the creation of value when companies work together. And today, many of these connections are supported or even enabled by digital technology. And we all know that this phenomenon of increasing amount of connections between companies around the world is called globalization. And that's why it's so interesting to take a closer look at networks and how networks actually work and what's the foundation that is behind these networks. Let's start our journey by looking at the basics of a network. What is a network? A network is a very simple model. It consists of a collection of nodes, and all these nodes are connected by links. In mathematics, the same concept is known as a graph, and nodes are called vertices and links are called edges. Now let's have a look at the properties of a network model. And the network model is a very interesting model also for science and research because it has many, many interesting properties. First of all, the network is highly scalable. You can have small human-readable networks, like the example we have here, but you can also go up to models with millions of nodes. Usually you cannot visualize those networks in a proper way, but you can use computer models to work with them. The second thing is that the meaning of the nodes and the links in the network can be defined freely and on every level of detail. That means it's up to you what you want the model to represent, which type of information, which type of entities, and which type of connection between them. And finally, the network model, although it is very simple in its basic form, it can also be enhanced by many, many additional aspects. So for instance, you can add link direction, which you indicate by converting the links into arrows to indicate in which direction the flow between the nodes can happen. And you can also add link weights. That means you add some kind of number or additional annotation to the links so that the intensity of the link gets a kind of meaning. And you can even go beyond that, not just take regular numbers, but you can also create fuzzy links by using probabilities if links exist or not. So there are many, many, many different possibilities to enhance your model and to tailor it to the needs and to the type of real-world phenomenon that you want to describe. Let's look at an example from my personal research. This is about complex networks in manufacturing. So if we want to work with such type of network model, we need two components. First of all, we have to select the network model that we want to use. And in this case, it's just the graph that represents the material flow on the shop floor. And the second thing is what we need data to create the actual model, the representation of our factory and the material flow. And in times of Industry 4.0, we have many, many opportunities to receive data, for instance, in manufacturing, but also in transportation and logistics, or we can receive data from infrastructure archives. And that means we use this data that has been created for different purposes in the first place, but we can make use of this to create our network model. Here you can see the two example pictures. These are two different material flow networks in manufacturing. First example is the material flow in a job shop, which is, I would say, more evenly distributed. So there's material flow happening between all the different workstations to a certain extent. And in the second example, it's the same technique, the same model has been used to create this material flow picture. But this time this was material flow data from process industry. And you can already see by just looking at the network model that here the situation is a little bit different. You have very intense material flows in the first stages where you seem to have some kind of standardized first production steps, and then the material flow splits into different clusters where the final products are being processed. Now let's take a look at some different ways on how to create network models from actual data. We have numerous possibilities to collect our data and to create network models in manufacturing and logistics. First possibility is that we focus on open data, for instance on air traffic data or data from road and railway networks. There are many sources on the internet where you can find tables, databases that give you information on these types of infrastructure. For instance, what type of airports do you have in the world and how are they connected by flights? But you can also download network data on road networks, on railway networks. Sometimes these are published by authorities. Sometimes these data were collected by organizations and then published on the internet for investigation and research purposes. So this is a very good source to start with network models because this data is publicly available and you're most likely able to find very interesting data that you can use and that's just ready to work with and do some kind of network investigations with that. Well, second possibility would be to use company data, and this is of course particularly interesting if you want to use manufacturing data, if you want to use supply chain data, because this is usually data that's inside the companies. It's their private business data. And if you have contact to companies that are willing to give you this data or which engage in a research project with you, then you might be able to get this type of data. This could be, for instance, supply chain relations. So the companies could give you information on their suppliers, for instance, on their customers, so that you can create supply chain relations with that. They might give you shop floor data, as you've seen in the example on the previous slide, but they might also give you transportation schedules from their deliveries, so that you can use this data to create a network of transportation from this. The problem with company data is often that it's confidential, and companies are not very much interested in just giving this data away for free to anybody, because it of course also contains business secrets, or it could be used to investigate the performance of their company, of their activities and processes. That's why you mainly only get this data if you work very closely with those companies in a research project. Sometimes they are willing to give you this data in a kind of anonymous fashion, so the data which is then somehow pre-processed, that there is maybe some information changed regarding the performance or regarding personal data, customers and suppliers. Can be difficult to get those data, but if you are in contact with companies, it's a very good idea to go to that data source, because it's usually very reliable, and of course it's the main focus of any research in the field of logistics, if you want to find out more about company processes and also improve those processes. And a third possibility to gather data is so-called web scraping. It's similar to the open data, but web scraping means you also try to get data which is publicly available, but it's not ready-made in a shape that you can just download it as a table, but you're more looking at other data sources on the internet, and use specific software products to download the data and then in a post-processing step bring it in the proper shape. This could be, for instance, train schedules. Usually there are websites where you can just query any train connection. So there are programs available where you can then try to, by sending a lot of queries to this train website and to the scheduling website, just receiving all the possible schedules and then creating from this a network, for instance. What else could you do, for instance, if you want to look at the connection between people, how they are connected in a network? Social media is a very good source. You could go to websites such as Facebook or LinkedIn and try to figure out who's connected with who to create a kind of social network from that. You have to be careful. Some of these companies, they don't allow the mass downloading of data, so you always have to make sure that if you collect this type of data, that it's actually okay to do that. Now, once you've collected all the data, how can you actually create a network from that? Usually you have all the data that has been provided to you in a tabular fashion, kind of a list of events that happen in a certain order. For instance, trains stopping at different stations or material being transported from one workstation on the shop floor to another. So in the end, it could look like this small example table. You have a different order on the shop floor, or it could also be a bus or train number that's visiting different stations at a certain point in time. And now, by ordering this table, grouping it by the actual ID, and then ordering by the station in terms of time they have been visited, you can figure out which node, which station in the network is connected to which other station by a transfer. So in this example, you would figure out that from the first part here, there is a connection between A and B because there's a consecutive movement in time from A to B in this network. Then you look at the second event, which has 3 items. There's a consecutive movement from A to B to C. So in this case, you have another movement from A to B. You can, if you want, increase the counter here and then add the second link from B to C. And if you look at the third event here, there's a movement from B to D. So you would also include that in your network. And in this very small example, you have already created a graph, a network from this tabular data that you have collected. And now if you imagine you have hundreds of thousands or even millions of entries, you can create a quite large network from that. We have already looked at some examples on how data can be collected to create network models. But now I also want to focus on the possibilities, how data can be collected in the age of Industry 4.0. Even logistics has entered the age of Industry 4.0, and I think logistics is a main component of Industry 4.0 because there's so much happening in this field and there's so much possibility and so much opportunity for digital support. And also with the advent of cyber-physical systems, we can observe that the control of logistics processes with digital tools has increased a lot. And by using digital tools to control logistics processes, you also have the second side of this, which means you can also collect a lot of data about the processes. It's not just about controlling those processes, but also about collecting a lot of data. And aside from the examples that we've seen, we can also structure the data collection by the different ways or where this happens in the organization. So first, we can collect data in a horizontal fashion along all stages of the chain of value creation. That means, like in our examples, we follow a product, we follow a customer, a traveler through the network with all the stations that are being visited, and from that we can create our network model. But we have many more possibilities to collect data. We, for instance, could also focus on the vertical collection of data on all management levels. So we don't have just to look at the lower level, at the operations in logistics. We can also look on plans that are created, on planning. We can look on financial flows. We can look on projections of future activities. So anything that happens on different stages of management, not only on the operational level. And we can also make use of that data here. The third thing is the collection of data along the complete product life cycle. So if we look at the horizontal data collection, it's rather focusing on the processes and the stages that we visit, but we can also focus on the product and follow the product through its entire life cycle. And that means from the creation in the factory via the transportation to the customer, and then also during its lifetime there, while it's being used by the customer, and including any additional things, maintenance that happens afterwards. So to sum up, the idea is, or the opportunity is, that we have extremely inexpensive and straightforward use of sensor hardware, and we can use that in combination with computational power and data storage that we have these days. And this allows for a data collection and processing of data in the complete network. So it should be very easy now, and even easier in the future, to collect all this data that we need for our investigations. Now, what can we do with the network model that we've created? There are many opportunities for analysis and quantification of networks. There's this saying in management: you can't manage what you don't measure. So we can make use of the network model and look at new types of KPIs away from financial perspectives, but we can find out a lot about our infrastructure, about our network itself, and we can make use of this information in decision making anywhere, like in strategic decision making, but also in operational decision making, by looking at the infrastructure that we have at hand, and by making use of the numbers that we get from this. So what could we do here? We have, for instance, the path lengths and shortest paths that are usually calculated when looking at networks. That means we can figure out how quickly are two items in the network connected with each other, what are the shortest paths to make them connected. The second thing is the whole family of centrality figures. We can check the centrality of nodes, and we can use rather simple and straightforward calculations like the node degree. That means we just count the number of neighbors of a node to determine how important it is in the network. But we could also use more sophisticated key figures like the betweenness centrality. That is the number of shortest paths that pass through a node. So we calculate all shortest path of each pair of node in a network. This can be very much if you have thousands or millions of nodes. So you definitely need computational power for that. And then you can identify the number of shortest paths that run through each node for instance, as a proxy or to determine how important it is. If you look at the example here, the green network, you can see that the green node in the middle, although it has very few connections, it's just connected to two different other nodes. So by just looking at the number of neighbors, you would expect this node to be not very important. But apparently you can see that it must lie on many shortest paths, all the paths that connect the left or the right part of the network. So this node is definitely a very important node. Here again in the small network, of course, you can already figure this out by visual inspection, but in larger networks this is not so easy, and that's where these key figures can be very useful. Another thing that you often do is clustering. You can identify clusters in the network. You can calculate the clustering coefficient. That means how much is the connectivity in a group of neighboring nodes, just to figure out if a node in your network is rather highly connected within its neighboring nodes or rather sparsely connected, for instance in a transportation network, to figure out how easy it is to find a detour or to get to any other node in the network, or if your node is rather isolated here. And still, visualization is a very important part of the network modeling. Although we can make use of the key figures and the numbers, a picture is sometimes just more important to make things clear. So you can use network pictures to make certain structures visible. And you can also use that to identify clusters. I just want to get back to the picture that you have seen earlier from the material flow in the process industry. And here again, by just displaying this picture of the network, you can easily identify these phenomena here, that you have the high intensity of material flow in the beginning for the standardized part of the processing, and then the specialized part in the later part, because the material flow is not so intense anymore. And you can easily see that there are certain clusters which show the different factories, the different locations where the final processing is done. Additionally, network models and especially the network key figures can be used for risk assessment and forecasting. This is what can be very useful if you have the network model. For instance, you can use the key figures that you've already seen to identify important nodes. And by having identified these important nodes, you can already say that these nodes may be at risk. If these nodes are being attacked or being knocked out, then the whole network might get in trouble, because these nodes have a central role in the network. There's a lot of material or traffic or people visiting these nodes. And you can go one step further and also use computer simulations within your network to figure out how strong your network is. That's usually called a knockout analysis. That means you simulate the change in the connectivity of the network when the nodes are deleted. And here's a picture from one of the research investigations I did together with other researchers, where we were looking at a road network and or different road networks. These are the different colored lines here. And we were removing links, starting with one link and then adding, removing another link in the network and so on, just counting and continuing to remove links when we go more to the right side in the graph. And we were measuring the network failure frequency. So we were measuring how likely is it after we have removed a link that the network will fail. This can happen in different fashions. Network failure could be the network is disconnected, so you are no longer able to get from one side to the other, or a network gets congested because there's no more capacity to serve all the movement within the network. It's up to you how you want to define this. And here in this research you can see that these different networks that we have investigated have different properties here regarding their strengths. Some networks can easily fail, so by just removing 2, 3 or 4 nodes you already have a failure frequency of 80%. That means these networks are very, very vulnerable. And if you look at other networks here that have been investigated, the lower curves, there it takes much more links to be removed before these networks have a high probability to fail. So you can use these type of information, these key figures, to perform various analyses with your network. And this is another example from some scientists that have made use of the network data they have gathered from a public source, and they have made a complete analysis of this network with very many aspects. And I just picked 2 of the aspects that I want to show here from their publication. On the left side you can see the identification of communities or clusters in the network. This is the railway network of India. And here in this visualization you can see that there are certain clusters in the network, and well, it helps you to figure out that in your infrastructure there seem to be some strongly connected components, some parts where people and goods can easily travel, easily be transported, but they are maybe not so much connected to the other parts of the country. And of course this is something which gives you some insights, for instance, about the strategic planning of the future development of the network, how you want to invest into your railway network, or even gives you some insight about risks, what could happen if some important connections will get lost due to natural disasters or due to attacks. And well, it also gives you some more information what to do in the future when further developing your network here. And on the right side you can see something which is similar to the knockout analysis that we've seen before. Here the investigation is similar, but it goes in both directions here. So first of all, there have some stations been removed in the network. Here you can see the fractions of stations being removed up to 100%, all stations being removed, and you can see the difference between, or the difference on the impact of the network between the 2 scenarios. Random failure, which means stations are just randomly picked and being shut down. How does this affect the functionality of the network? And you can see it looks like almost a linear decrease of the functionality. Random failure could be something connected to natural disasters, to just power shortages, whatever. And then you can see the other curves which do the same investigation, but this time using targeted attacks. So what would be if whoever would focus on the most important stations in the network and shut those down. And here you can see that there's much steeper development, and you can see that the network gets much quicker in a critical state. So you can conclude from this that it would be very important to protect these stations or have more maintenance to keep them running so that your network remains functional. And on the right side, it's basically the same thing but reverse for the recovery. What should be your recovery strategy if you want to recover from an impact? What stations should be focused? Should you choose them somehow randomly, or would you focus on different types of stations, again selected by network figures, by number of connections, but also by centrality, for instance, to make the network functional as fast as possible. And the research on complex networks is still going on, and there are many things being researched, and I want to show you some research from my current and most recent works. The stochastic block model, this is a certain type of network model that can be used. The basic concept here is that you use probabilities to model a network, so you don't model the actual nodes and links between them, but you group nodes together if they are likely to be connected to other groups of nodes in the network. So you could say somehow you model the clusters and the probabilities how they are connected in the network. You can use some statistical or stochastic techniques to figure out what is the best representation. After that, this model can be used, for instance, for link prediction, because now you have the probabilities if links should exist or not, and you can use that in your supply chain or in any other type of network to make some strategic decisions, because you now have the probabilities that two components will be linked or should not be linked together. Okay, so let's sum up. What have we seen here? We've talked about complex networks in manufacturing and logistics. And the first thing that we've seen is that the network model is simple, but at the same time also very powerful due to its flexibility. We can have a simple network model, anybody can understand how this is created, but that we can enrich this with additional features, with additional properties, so that we can model even complex situations here. Second thing is that we've seen that the technological development of Industry 4.0 makes it easy for us to collect data and to process this data, so we can now make use of very, very large network models and also the different types of key performance indicators that we can receive from the network data. And the third thing is that network modeling offers a powerful tool to transform network-related aspects into these KPIs, also for managerial purposes. We've seen that network infrastructure can be quantified, it can be transformed into numbers, and therefore it can also be used for decision making and management on all the different levels, on the operational level, but also on strategic levels. Finally, we can see also continuous innovations in network research. There are, for instance, the stochastic approaches that we can use to predict future states of the network and also include this in our decision-making processes in the future. Thank you for being here and thank you for listening. I will be glad to answer your questions. Maybe you want to take a screenshot of this slide here, then you can just send me an email if you want. I can get in touch with you and answer your questions. You can also have a glance at my publications. Many of them are focusing on the topic of networks in manufacturing and logistics. I will be happy to discuss with you, and I'll also be happy if some of you are inspired to also do some work and investigation in the network field. Feel free to contact me. Thank you for being here.